The younger sibling's swimming speed is 6 feet per second, and the older sibling's swimming speed is 9 feet per second. The total length of the swimming course is 90 feet, and the younger sibling starts 27 feet ahead of the older sibling. Can the older sibling catch up? This problem can be intuitively solved. The speed difference between the two is 3 feet per second, and since the younger sibling started 27 feet ahead, it would take 9 seconds to cover that distance. The older sibling takes 10 seconds to reach the finish line, and the younger sibling takes 10.5 seconds, so the older sibling catches up 1 second before reaching the finish line. If we formulate the situation with a system of equations, let the distance traveled after x seconds be y, in feet. For the younger sibling, it is y equals 6 times 27. And for the older sibling, it is y equals 9x. Solving the system, we get 9x equals 6 times 27. This is called the substitution method, which gives x equals 9. Thus, the older sibling catches up after 9 seconds. Let's graphically represent this. First, the graph for the younger sibling is shown in blue, with a y-intercept of 27, indicating the 27 feet head start. The graph for the older sibling is shown in red. The intersection point of the two lines is 9:81, meaning the older sibling passes the 81 feet mark after 9 seconds. The point where the red graph intersects the y equals 90 line is 10:90, indicating the older sibling crosses the finish line after 10 seconds. For the blue graph, it intersects the y equals 90 line at 10:5:90, meaning the younger sibling crosses the finish line after 10.5 seconds. In cases like this, where two different equations represent the situation, they are referred to as a system of linear equations. The values that satisfy both equations are known as the solution of the system, and they are represented by the coordinates of the intersection point on the graph, as we observed with 9:81 in the graph we drew earlier. Solutions of the system of linear equations often have a unique solution, as in the example above, where the intersection point is the only one. However, there are cases where there is no solution, indicated by two parallel lines with the same slope that do not intersect. In such cases, we say there is no solution. On the other hand, when two lines perfectly overlap, we say there are infinitely many solutions. A system of linear equations can be solved either graphically or algebraically. There are two main algebraic methods: the substitution method and the elimination method. In the next session, we will delve into these two methods in detail. See you next time!